We're going to talk about the domain, the range, and the period of the sine, cosine, and tangent functions. If you need help with how to graph the functions on the calculator, see the video about graphing trig graphs on the Nspire. Okay, when we're looking at domain and range, domain is the set of all possible x values for the function, or all possible input values. In other words, in this case, theta, the angle. So what's all of the possible angles I could use for sine and cosine? Well, if I go around the circle once, it's 0 to 360, but I could keep going around the circle and keep going around the circle and keep going around the circle. I could go backwards around the circle. So the domain for both sine and cosine is going to be all real numbers. So I'm going to put a little D for domain, is all real numbers. There's two other ways to show this, to say this in math. One is a big R with kind of a double bar. Another way is to say that x is an element of negative infinity to infinity. That's called interval notation, which is something you're going to see mostly in college, and you'll see that almost exclusively in the college textbooks, so you want to be familiar with doing that sort of notation. So x could be any number, or the angle that we put in could be any number for sine and cosine. Now the range is all possible y values, or the outputs. In this case, we're talking about the trig values. So what trig values can I get for sine and cosine? Well, for both sine and cosine, you will notice that the highest that you can go is 1, and the lowest you can go is -1. Highest is 1, the lowest is -1, no matter how many times the graph repeats themselves. So we say the range is that -1 is less than or equal to x, is less than or equal to y, is less than or equal to 1, or in interval notation we use a closed bracket, -1, comma 1. The square bracket indicates that -1 and 1 are included in the interval because the -1 and 1 are the endpoints. So if I just wanted to say, for example, I'll just put this kind of over the side, if I wanted to say -1 is less than x is less than 1 and it's not included, then I would just say -1 to 1 with a curved bracket. But we want to have the square brackets. Now let's look at tangent. Tangent's a little trickier. So when we look at the domain, we have to remember we've got some asymptotes here. And I didn't do the scale terribly well on this tangent graph, but hopefully you remember where these asymptotes would be. This is at 90 degrees and at 270 and at -90 and at -270. So we are not allowed to use x values where there's an asymptote because there is no corresponding y value. So when we talk about the domain of the tangent value, we have to say all real numbers except positive and -90. Actually, a better way to say that. How do I say that? I can't say multiples of 90 because 180 isn't an asymptote. What I do know is if I start at 90 and I go 180 this way, I'll get to another asymptote. If I go 180 degrees this way, I'll get to another asymptote. So I'm going to say all real numbers except 90 degrees plus 180n. You could say plus or minus 180n if you want to, although plus 180n is actually sufficient if you say that n is an integer. In other words, n could be -1, -2, -1, 0, 1, 2, etc. So if n is an integer, I don't even really need the negative sign. I can just say 90 plus 180n, and that would include 90, and I can add or subtract all multiples of 180 to either add or subtract them from 90. Now the range, this continues infinitely in all directions. So all possible y values are included in the domain, or in the range. Sorry, we can the slope can get as high as we want it to. It can get infinitely high. So the range in this case is all real numbers, or negative infinity to infinity. Now when you get to the reciprocal functions, the domain and ranges are a little trickier. I'm not as concerned that you know them, but do know where they're undefined. Do know their limitations. If you can't state them, you can state them in words, but you don't have to show symbolically what those are.